just have to make sure that we develop it that way. Okay. So the key point to take away from that is that, scaling is not always about demo programming. It's kind of all about managing how people use your service as well. And Python is great for this, and also because it allows us very rapid feature development. Get those features out in front of the studios pretty quickly. All right. Even if you've, have a well-designed feature, it also helps to have a pretty kick-ass architecture in place, so that you're able to scale up your user numbers. So there's a few tricks that you can use to make sure that services can scale correctly, and they mostly revolve around being able to spread read and write requests and their data storage across an arbitrary number of machines, depending on the requirements of that service. So these are the kind of tricks that we use. But what we have is a really nice internal library written in Python that wraps all of this behavior. So this is kind of, managing data that's spread over multiple data sources can be pretty tricky. So what we have is a really nice Python wrapper around this that basically insulates all of our developers from the underlying distribution of data. So all they can do is just develop the service and just have one test database running in the background. Then our operations team at launch can just start adding machines to support that service or take them away. And it's just the same application code as running. The application just doesn't need to be aware of how the service is, how the data is distributed underneath. Okay, here's how our architecture works. I kind of talked a bit about it in my first slide, but I just go into a bit more detail about it here. And you can see, this core architecture, which we kind of first went along with, is still in place here. What we have is a games console, or